Hey everybody, this is Larry. This is me going with Q3 of the Leetcode bi-weekly contest 44 Decode XORed permutations. Hit the like button, hit the subscribe button, join me on Discord. For me, this was a very hard problem. I think like almost 1,000 people solved it. And to be honest, I did not solve this during the contest. I was caught a little bit between solving this one and Q4, and I ended up solving neither. This was actually my worst contest ever, but it happens. I need more sleep. That's my excuse. I'm sticking to it. But so I think this is one of those problems also where reading the code, it takes a lot of practice, and like for me, I didn't understand from code review as well, and I'll have a link below. You can watch me try to solve it during the contest, because it's really long because I didn't solve it, so I'm not going to make this part of this video. But in the end, I also go over me doing a code review and then coding this from scratch after that. But we'll go over my solution here. And again, if you look at this code, it doesn't really like, it's hard to understand what's from this, but the idea here is that, okay, you have an XOR, you know, let's say you have sorry, let me ask you out this a little bit and also make this a little bit bigger for you to see, maybe a little bit smaller. So basically you have, you know, you have a sub 0, let's just call it a0, a1, a2, a3, dot dot dot, an, right? So then, you know, so basically you want the sum, which is this, we have the XOR sum, dot dot dot, xn is equal to some x sum, right? And of course, the key thing to note is that the numbers here are the numbers from the first n positive integers, right? So that means that this is always going to be the same given the same n. Actually, so it doesn't really, and also with XOR, it's which one is the commutative? Is that the one? It's commutative, so you can, you know, permutate them in any order and you still get the same answer. So this is why, this explains the part of the code where I just go from 1 to n and then get the XOR sum. And then now, the thing is that, okay, we have this x encoded away, and the thing that we want to do is try to figure out the first number, right? And the first number is just, you know, if we have the suffix sum, the suffix XOR sum, let's just call it this. Let's just actually use words. I don't know why I use. Right? If we have these two things, then we can XOR the two things because this cancels out with this one, right? And then the hard part, and that's the part that I didn't, I actually, to be honest, during the contest, I didn't think about this at all. But it turns out, of course, that given this encoded array, you know, so the encoded array tells you, you know, XO plus XO x1, x1, xa2. I keep on saying x, but I meant a, 3, dot dot dot. I mean, as you may know, right? So you have this, and wait, let me actually do one more. 3 to a4, a4, a5, dot dot dot, right? And so how do you get this thing, right? Well, if you look at all these numbers, then and that's basically the idea, is that for this encoded number, because you know, to get, you know that this is the case, so to get this, you can kind of iterate through it, and this is really hard. Even well, I mean, I didn't get it during the contest, right? But if you encode, if you do this one, you take this number, the first thing, so you have this a2, you take this number, which is a3 XOR a4, and that's pretty much the idea, right? And the other thing to note is that n is odd, so you don't have to do anything weird with the n. But you know, you could do a parent on it so that's a little bit clearer. But basically, this is the suffix, is that we look at every other encoded thing, which is what I do here. And once you do that, then as we said, you could cancel this out with this out and to get the first number. And once you have the first number, all the other numbers follows through. And that's basically the idea behind this problem. In a way, it's greedy and also just math, arithmetic manipulation, which I was not able to do during the contest, as I mentioned a few times, because I think I needed more sleep. I only slept like 2 hours. Gotta stop watching those movies up at night. But yeah. What is the complexity of this? I mean, I think if you're able to understand this, it should be straightforward, which is that the space is output sensitive, so it's O of n, and you cannot do better because that's the size of your output. In terms of, running time, is going to be O of n as well, because, I mean, like we have 3 loops. Each of the 3 loops have n elements, and they do all 1 constant time. That's what I have for this problem. Let me know what you think, and I will see you next problem. But yeah, you can also, I'll have a link below to the contest itself, and yeah, but that's basically this idea. I will see you later. Bye bye.